Lesson 91, solving absolute value inequalities. So let's review what absolute value inequalities are. They're just inequalities with at least one absolute value expression. And the solution is written as a compound inequality. And remember, we can either have conjunctions or disjunctions. And just some rules for solving absolute value inequalities. Or an inequality in the form of the absolute value of k, when that's less than a, k represents a variable expression, and a is greater than 0, you would solve negative a is less than k, which is less than a, or if k is greater than negative a and k is less than a. So if you have the absolute value is less than a value, then it's a conjunction. So you use and. For an inequality where the absolute value is greater than a, then you would use the keyword or because it's a disjunction. So let's look at this first example. The absolute value of x is less than 4. So I have to write that as an inequality. Since it has less than, it's a conjunction. So x can be less than, x should be in the middle, so it can be greater than a negative 4, or it can be less than a positive 4. And then I just graph it. So negative 4, negative 2, 0, 2, 4. Open circle on negative 4 and 4 going towards each other. Next one, the absolute value of x is greater than 7. Since it's greater than, I need to use or. So x can be greater than negative 7. Be greater than 7, or x should be less than negative 7. So it's just meaning the absolute value has to be more than 7 steps away from 0. So more than 7 steps away from 0 to the right is bigger than 7, or if more than 7 steps to the left of 0 is less than negative 7. And going back to that one, you got to graph that one, so let's graph this. This would be negative 7, negative 5, negative 3, negative 1, 1, 3, 5, 7. Open circle on both negative 7 and 7. They go in opposite directions because of the or. Next one, absolute value of x is less than 12. So that means they have to be 12 steps away from, it has to be less than 12 steps away from 0. So this is a conjunction, so less than 12 steps or greater than negative 12 steps. So when I graph that, put a 0 in the middle, I'll have 12 here, I'll have negative 12 here. So I'll open circle on both ends. Since it's a conjunction, they join with each other. Next, solve and graph this one. This is a disjunction because it's greater than. So if it's more than 19 steps in either direction, more than 19 to the left would be less than negative 19, or more than 19 steps to the right would have to be greater than 19. So now I draw our number line. I have 0 in the middle. We got negative 19 to the left, positive 19 to the right. We have open circle on both, less than 19, negative 19 going to the left, greater than 19 going to the right. Second type of problem, isolating the absolute value to solve. So we need to isolate it first before we determine what kind of conjunction it's going to be. So I need to get this by itself, so I'm going to subtract 7.4 on both sides. I get the absolute value of x is less than or equal to 2.4. Since it's less than or equal to, I know it's a conjunction, so I can have x in the middle. It's less than or equal to 2.4 on the right-hand side, or it would be greater than or equal to negative 2.4 on the other side. On number line, 0 in the middle, 2.4 to the right, negative 2.4 to the left. Filled in circle on both. They go towards each other because it's less than 2.4 but greater than negative 2.4. Next one, to get absolute value of x by itself, I multiply by 4 on both sides. I get the absolute value of x is greater than 8. It's more than 8 steps in either direction. This is a disjunction. More than 8 steps to the left has to be less than a negative 8. Or x has to be greater than 8 to the right. So number line, 0 in the middle, 8, negative 8. Since it doesn't have the equal to sign, we have open circles on both circles. Less than and negative 8 means going to the left. Greater than 8 going to the right. Next, get absolute value of x by itself, so I divide by negative 2. Because I'm dividing by a negative number, I need to flip the symbol, so now it's greater than 3. Because it's greater than, it's an or, so I have x is greater than 3, or x is less than a negative 3. And my number line, 0 in the middle, negative 3 to the left, 3 to the right. Just greater than and less than, so open circles. Greater than 3 going to the right, less than negative 3 going to the left. Next one, divide by negative 3. Since I'm dividing by a negative number, I have absolute value of x is now greater than or equal to a positive 3. Since it's got the greater than part, it's an or, so x is greater than or equal to 3, or x is less than or equal to a negative 3. So on number line, 0 in the middle, negative 3 to the left, 3 to the right. Has the equal to part, so we filled in circle on both 3 and negative 3. Greater than or equal to 3, so to the right. Less than or equal to 3, going to the negative 3 to the left. Example 3, solving inequalities with operations inside the absolute value symbol. So when we take this out of the absolute value, I have, since it's less than or equal to, I know it's a conjunction, so I have x minus 5 has to be less than or equal to 3 to the one side, or greater than or equal to a negative 3 on the other side. So it's 3 steps away on both sides of whatever x minus 5 is. Now I solve by adding 5 to both sides, and I have x is less than or equal to 8, or it's greater than or equal to a positive 2. And graphing it, I have 2, 4, 6, 8. We got a filled in circle on 2, it's greater than. Filled in circle on 8, it's less than, so they join up. Next one, x plus 7. The absolute value of x plus 7 is greater than 3. Since it's greater than, it's a disjunction. So I have x plus 7 is greater than 3, or x plus 7 is less than a negative 3. Now to solve that, subtract 7 on both sides. I'm going to do that for both. And I have x is greater than negative 4, or x is less than a negative 10. So to graph it, or negative 10, negative 8, negative 6, negative 4. open circle on -10, open circle on -4. It's greater than -4, so it goes to the right. It's less than -10, so it goes to the left. Next one, solve here. Since it's less than or equal to, that's a conjunction. So I can have x minus 10 is less than or equal to 12, or it's greater than or equal to a -12. So this is nothing new to what we were doing. It's just we have the absolute value involved with our inequality. So to get x by itself, I add 10 to both sides, and I get 22 this side, and -12 plus 10 is -2. So on our number line, we got -2, 0, 2, 4, 6, 8. I'm going to have to jump all the way over to 22 here just to keep some space. So I have an open circle, or a filled in circle on -2, filled in circle on 22, going to the left. So I would have that as my answer. Next one, it's greater than 18, so it's an OR. So x plus 12 has to be greater than 18, or x plus 12 has to be less than a -18. Subtract 12 in both equations, and I get x is greater than 6, or x is less than a -30. So I have a -30 here. We'll have 0 over here, and then 6 here. I have open circle on -30. Less than means it goes to the left. Open circle on 6. Greater than means going to the right. And a couple special cases. Here, first, get the absolute value of x by itself. So I'm going to subtract 6 on both sides. The absolute value of x has to be less than or equal to a -2. Well, because it's less than or equal to a -2, anything that comes out of the absolute value cannot be negative. Therefore, there is no solution to this one, because everything that comes out of the absolute value of x has to be positive. So it can never be less than a negative number. Next one, subtract 6 on both sides. You have the absolute value of x is greater than -5. Since this inequality states that the distance from 0 is greater than -5, all distances, the absolute value, are positive. So all the numbers on the number line are solutions. So this should be all real numbers. Because I can put any number in for x and find the absolute value of x, it's always going to be greater than a negative number. So if the inequality is greater than a negative number, it's always all real numbers. Next one, absolute value of x plus 3 is less than 3. I subtract 3 on both sides. I get the absolute value of x is less than 0. For this one, because it's less than 0, that would be impossible, so no solution, because anything that comes out of the absolute value is always going to be greater than 0. It's going to be a positive. It can equal 0, but it can't be less than 0. And the last one, subtract 21 on both sides. Absolute value of x is less than or equal to a -7. You can't get any number that's going to be less than a negative, so this would also be no solution. And some application. A machine part must be 15 plus or minus 0.2 centimeters in diameter. Write an inequality to show the range of acceptable diameters. For this one, we know we have the absolute value because of this plus or minus 0.2. So we have an absolute value, And we can use the machine part, so M must be, so if the difference of wherever the machine part is in 15 has to be less than or equal to 0.2 in either direction. So that would be our inequality. And why did I have less than or equal to? So it can't be more than 0.2 direction in either direction. So that's why it has to be less than or equal to. So it can equal to 0.2. And the absolute value is because of this part. Now solve the inequality to find the actual range for the diameters. So to solve that, because it's a less than or equal to, it's a conjunction. So if I put m minus 15, it's less than or equal to 0.2 on the high side, or greater than or equal to a negative 0.2 on the low side. To get x or m by itself, I add 15 to all three sides. The machine part can be less than or equal to 15.2 centimeters in diameter, or greater than or equal to 14.8 centimeters. That is our lesson today on solving absolute value inequalities.